Here's example 1. First thing we're going to do is we're going to assign oxidation numbers. This is hydrochloric acid, so I know this is an acidic solution, which I'm going to assume it's an acidic solution unless I'm told basic. So this K2 means that the polyatomic ion, this is called dichromate, also has a charge of -2 because I have 2 pluses in front. So this diatomic ion has to have a charge of -2. So I'm going to need 2 extra minuses, or you can also think of the entire compound's going to add up to 0. So -14 plus 2, so these guys each have to be a +6. Go across and assign oxidation numbers. Chlorine is a 0 because it's in its elemental state. So let's go over what's happening here. The K's do not change, but the chromiums do. So Cr2O7, 2 minus, goes to Cr3 plus. And the other thing that's changing is chlorine goes from a Cl minus. Over here, these two guys, they're Cl minuses too, so that's not changing, but some of it does go to Cl. First thing I'm going to do is balance everything that's not oxygen or hydrogen. Then I'm going to add water to balance the oxygens. And then I'm going to add H plus to balance the hydrogens like such. So everything right now is balanced according to mass. And now we need to balance it according to charge with electrons. Right now on the reactant side here, I have 14 pluses and 2 minuses. So that adds up to a total of +12 on the reactant side. And we have 2 times +3. Put it over here. So +12 on the reactant side and +6 on the product side. So I need to bring the +12 down to a +6 with 6 electrons. 6 electrons go on the more positive side. Down here, I have 2 electrons in the reactant side. I have charge of 2 minus on the reactant side, so I'll add 2 electrons to the product side like such. If I multiply this by 3, that will give me the right coefficient. So let's just distribute that 3 out with all of them. So this is a 6, 3, 6 electrons. Next step, let's double check. We need electrons in the same quantity on the reactant side as the product side. So I have 6 electrons on the reactant side, 6 electrons on the product side. That will cancel. And my final answer is everything that is left behind after the problem is over. This is the final answer. Don't worry about putting the spectator ions back in. Nobody cares. And if somebody asked you how many electrons is being exchanged in this particular problem, you would say 6.